Hello and welcome back. In fluid kinematics, we study motion of fluid particles. In this video, we discuss about the concept, velocity field. Consider a particle A, moving along a path. The position of the particle, at a given time t, can be represented using a position vector, RA, in the Cartesian coordinate system. Consider a small movement of the fluid particle for a period delta t. The new position is, RA, at t plus delta t. We know that the velocity of particle at a given instant is the rate of change of its position at that instant. Imagine fluid motion as motion of fluid particles. Each fluid particle will have a velocity, at their respective locations, for a given instant of time. The collective representation of velocity vectors is called a velocity field. Consider flow of a fluid through a converging-diverging channel, as discussed in video 30. Consider three locations A, B, and C where we can measure velocity of fluid particle, passing through that locations at a given instant. Let V1, V2, V3 be velocities of fluid particles at these locations, at a given instant of time. In similar considerations, we can visualize velocity vectors of particles in the entire flow field. This is called a velocity field. A velocity field can be mathematically represented as a function of space variables and time. Let U, V, and W are scalar functions that give scalar components of a given velocity vector field V. Using this representation, we can identify velocity vectors of all particles in a flow field for a given x, y, z and time. Consider another example of steady flow of air around cylinder. The velocity field can be represented as shown in figure. The streamlines will be tangent to these velocity vectors or velocity field vectors. Hope you understand the concept, the velocity field. Thank you for listening.